Welcome to Chapter 1, Section 1.2. We're going to discuss number systems. The different number systems we're going to look at in this particular section are going to be Roman numerals, the Arabic number system, which are the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the decimal point serving as the anchor for those, and the place values. And then we're going to take a more in-depth look at scientific notation. The problem sets we'll work through are going to deal mainly with scientific notation, working on working to the left and to the right of the decimal point. Now, the important thing to remember with the Roman numerals is that the best way to master this is to just practice it. And you will see this a lot, both with the practice problem sets we're going to go through shortly, but also when you're actually looking at prescriptions, the physicians will use the Roman numerals. So it's important to practice on these problem sets and in the study partner CD and the practice test at the end of the chapter. So looking at the problem set on page 14, if we take a look, I'm going to go ahead and let you guys go through 1 through 12 yourselves, because those are pretty self-explanatory as far as following the Arabic numerals and the Roman numerals. So we're going to go ahead and take a closer look at scientific notation, and we're going to look, start off with number 13. Using the following number, list the quantity of each numeral in the named places. So the number we're looking at is 92,375.046. So number 13, we're looking at the 10th, and that's TH. The TH is what you're always looking for when you are working to the right of the decimal. We have the tenths, the hundredths, and the thousandths. Those are all with the TH. So that's how you know that you're looking to the right of the decimal if you are working with TH. So for number 13, we're looking at the 10th TH place, and that is going to be 0. Now if we look at number 14, we're looking at the 1000th TH place, tenths, hundredths, thousands, so that's going to be 6. And then number 15, the 100 DS place, and that is going to be 300. So it's pretty straightforward. It's just a matter of working to the left or to the right of the decimal point. Okay, so we're going to look at number 16. State the place value of the underlying digit. So the number is 18,240.6. And our underlying digit is the 2. So we know that that is hundreds DS. Number 17. Okay. 7.2391. Our underlying digit is right here. So we are working to the right of the decimal point, so we are dealing with TH, and that is the hundredths. TH. Tenths, hundredths, thousandths. Alright, so it's pretty straightforward, just a matter of practicing to get comfortable. Alright, if we flip to page 15, we're going to start writing numbers using without scientific notation and using them with scientific notation. So if you look at number 21, we have 6.8 times 10 to the 4th. So 6.8, and we are going to go 4 to the right because it's a positive. So 1, 2, 3, 4, and then we're going to fill our zeros in. That is the easiest way I can teach you to do it. And so this is where the decimal is at now. So 3 to the right is our comma, so 68,000. Alright, so let's look at the next one. Number 22. 1.87 times 10 to the 6th. 1.87. We're going to go 6 to the right because it's positive. 1, 2, 3, 4, 5, 6. And there's our decimal. And fill in the zeros. So now it's 1,870,000. Let's look at one where we're going to go the other way. Number 24, 8.4 times 10 to the negative fourth. So since it's negative, we know we're going to go to the left. 1, 2, 3, 4 decimal. So now it is 0.00084. The key is just getting to recognize whether you're going to move the decimal to the left or to the right. Number 25, 7.68 times 10 to the negative third. 7.68, and it's negative, so we're going to go to the left. 3. 1, 2, 3. And you can always put the 0 in front if you feel comfortable doing that. That's just a preference, whether you like to do that or not. Okay, so let's move down to number 27. Write the following numbers using scientific notation. So our first one, number 27, fairly small number. We've got 1, 2, 3, 4, 5, 6, 7 zeros. Okay. So let's start with our decimal and count until we get to here. 2, 3, 4, 5, 6, 7, 8. So we're going to rewrite that as 3.29 times 10 to the negative, whoops, and we went 9, not 8, sorry. I forgot a 0. Okay, let's look at 28. All right, so our decimal starts here, and we want to get rid of our zeros, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3.9 times 10 to the 11th, and that's positive because it is a positive number. The decimal is going to the left. All right, let's look at a couple of the application questions. Number 33, a patient is to take VIISS tablets 3 times daily. How many tablets must be dispensed to last 7 days? All right, so looking at the Roman numerals, we know that V stands for 5, and each one of these is 1. SS stands for 1/2, so we've got 7.5 tablets. They're taking it TID, which is 3 times a day. So if we multiply those together, take that times 7 days, we get 22.5 tablets. Okay, let's look at number 34. That actually shows a sample prescription. We have aspirin, abbreviated as ASA, and grain X, and it's 1 by mouth, QD. And we're dispensing C. Okay, so looking at a Roman numeral, question A, what is the strength of the tablet? We know that the Roman numeral X stands for 10, so it's 10 grain. For B, what is the daily dose? We know that that means 1, so 1 by mouth every day. And the quantity dispensed, C, Roman numeral stands for 100. Okay, let's look at number 36. Erythromycin. $250 milligrams. QID with food. And we are dispensing XXVIII. Okay, so the notation says that QID stands for 4 times a day. We're looking how many tablets are going to be dispensed. X is 20, or I'm sorry, X is 10, we've got 2, so that's 20. V is 5, and we know that these are 1, so we've got 28 tablets to be dispensed to the patient. And recognizing that QID means 4 times a day, this is 1 tablet, so we've got 4 tablets a day. 28 tablets divided by 4 tablets a day, and that's going to last us 7 days. Okay, number 37. Glucotrol, 5 milligram tablets. All right, question A. We want a 30-day supply. Can't forget that. How many tablets are taken each day? Okay, well, we've got 2 in the morning, 1 at lunch, and 2 at night, so that's 5 tablets a day. How many tablets will be dispensed? Well, they want a 30-day supply. 30 days times 5 a day is going to give us 150 tablets. And how long would C tablets last? Well, we remember from our last problem that C equals 100. So that is going to last us 100 divided by 5, 20 days. Okay, hopefully this has helped clarify any questions you guys might have. If you do have questions, feel free to post them to the Q&A discussion thread or to the virtual office. And good luck working out the rest of the problems on the problem set.